Welcome to the first task video for this week, where we take you through the task. Hopefully from listening in class you've realised that a precipitate is basically a fine solid in a liquid. So unlike when you dissolve something, the solid hangs around so that you can't get rid of it. And the idea is that there are solid particles. Solid particles which implies the liquid is opaque. Remember, opaque is the opposite of transparent. It's not see-through. Opaque is O-P-A-Q-U-E. So, an example of one would be, for instance, milk. You can't see through milk, but you can see through cordial. So cordial is a solution, but milk is a precipitate. Let's go up a little bit. Right. The crystalline precipitate consists of lots of small crystals. The gelatinous precipitate is jelly-like. Looks like there's a jellyfish in there, or a blob of jelly in there. And the amorphous precipitate is thick, and it's kind of formless. It's one big mess. It doesn't consist of little things inside. Okay, we now get to the key idea. And the key idea, the key idea here is that I start off with silver nitrate and potassium chloride in separate containers. So I've got a container in it that's got silver nitrate, so it means it's got Ag plus things floating around. It's got NO3 minus things floating around. I've got another container that's got K plus things floating around, because the potassium chloride and Cl minus things floating around. When I mix them together, I form a precipitate of silver chloride. So notice the sentence here, what happens when silver chloride forms. And therefore what I've got now is that the AgCl is together. It's not floating around anymore, but the remainder, the K plus and the NO3 minus, is floating around. So draw my little, so there's my containers, and that's in this container over here. So that's basically the idea, that when you get a precipitate forming, the bits and pieces join together to form a solid, and the remainder is still floating around as ions. Let's go, just before we go to the next page, if you're curious, how did I know it was Ag plus? How did I know it was NO3 minus? How did I know it was K plus? How did I know it was Cl minus? The reason I looked at my periodic table. On the left hand side I've written all the cations, so I'd find Ag plus and K plus, and on the right hand side of the anions I'd find NO3 minus and Cl minus. Okay, let's go to the next page. This next question is a fairly similar question, and you do a fairly similar thing to it, but you might like to think about the fact that you're going to in the end need to get rid of the water, so you're going to need to boil it at the end so the water can evaporate. Now we get on to the really interesting stuff, which are the solubility tables, and this tells you various things. So it tells you that lithium, sodium and potassium compounds are always soluble. It also tells you ammonium compounds are soluble, and it tells you any compound that's got nitrate in it, chlorate in it, or perchlorate is soluble. So So anything that you see with those compounds, you know is going to dissolve in water. It also tells you that most hydroxides don't dissolve in water, but the alkali metal hydroxides, that's lithium, sodium, potassium, they will dissolve in water, and barium will, calcium will a bit. It also tells you about chlorides. Most chlorides are soluble, and there's only a few that aren't. Silver, mercury 2, and lead. And most carbonates, phosphates and sulfides don't dissolve, but the alkali metals, which is basically lithium, sodium, potassium, will, as will the ammonium ion, which is that one. And finally, most sulfates are soluble, but the ones of calcium and silver aren't, and the ones of barium, mercury 2 and lead are definitely not soluble. Let's go and see whether we can use this in practice on the next page. So, let's try this first example out. Barium chloride is being mixed with sodium sulfate. Well, if you look at the last page, you'll see that chlorides are all soluble, with the exception of lead, mercury 1 and silver. But there's no lead, mercury 1 and silver in here, so we know that the chlorides are fine. However, the sulfates are different. When the barium gets in contact with the sulfate, if you look at the previous page, you'll see barium sulfate is insoluble. So therefore they will react together. So the answer is yes, a reaction will occur, and the products are going to be the particular things with the partner swap. So we'll get barium sulfate is one of the products. So now the barium goes with the sulfur to become barium sulfate, and that's a precipitate. And the remaining chemical therefore has to be the thing I haven't mentioned, which is the sodium chloride. And sodium chloride isn't a precipitate. And then if I'm then going to write it as a chemical equation, I then need to look up the formula. So barium's 2+, sulfate's 2-, so that's BaSO4 will be one of the things produced. I write a little S underneath to say it's a solid, it's a precipitate. And then my sodium chloride's the other thing, which I write as NaCl, because it's Na+ and Cl-, and I write a little AQ afterwards. The AQ tells me it's in solution. And on the other side, I've got to say what I've started off with. I've started off with barium chloride. Ba is 2+, but chloride's only 1-, so I need 2 of them, and they're in solution. And the others are in solution too, which is sodium sulfate, which is Na2SO4AQ. And then if I want to write it as a balanced equation, I need to notice something. And that's on the left-hand side, on my reactant side of the equation, I've got 2 chlorine atoms. But on the right-hand side, I've only got 1. On the left-hand side, I've got 2 sodium atoms. On the right-hand side, I've only got 1. So the other atoms are fine. I've got 1 barium there, 1 barium there, 1 sulfur there, 1 sulfur there, 4 oxygens there, 4 oxygens there. So it's just the sodium and the chlorine that are wrong. And so that I've got to realise that when this reacts, I don't just produce 1 lot of this, I've got to produce 2 lots of that, because I've started off with 2 chlorines and 2 sodiums. So I put a little 2 in front of here to indicate that I get 2 sodium chloride molecules. So for every one of those and one of those, I get 1 of those and 2 of those. And then you'll see that all the atoms balance. I'm not creating atoms, I'm not destroying atoms. If you need more practice on that, go and watch the keynotes video. moving further down. The others are very, very similar. Looking at the gas one, just show you how you'd think about the first one. This is very, very hard. Don't worry if you don't get to this point. There's a solubility product for calcium fluoride. Now, the way a solubility product works is you multiply the concentration of the ions together. If you've got an ion that's repeated, then you've got to repeat the multiplication. If you repeat a multiplication, that's like a power in maths. So if, for instance, in this one, we let X equal the concentration of the whole thing, and when it dissolves in water, the concentration of the Ca2 plus must also be equal to X, because there's one of those in there. So that for every one calcium fluoride molecule that dissolves, we produce one calcium ion, but we produce two fluorine ions. So the concentration of F minus is equal to 2X, because for one of these we produce two of these because it's CF2. So we therefore know that 4.0 times 10 to the negative 11, which is a very, very tiny number using scientific notation, is equal to X times 2X squared. Putting this back into this equation here, this is X, this is 2X squared, and so that we can therefore, using your ability to rearrange equations, a good practice for you, you should be able to work out what X is equal to. I'm not going to tell you any more here. You can think about this yourselves, just to let you know that it is fairly hard. But this is the key thing that you'll need to solve for X. Remember, you'll end up with a very small number because of the 10 to the negative 11, and even if you do things like square roots, cube roots, or whatever you need to do, it will still be a small number. Okay, let's move on to the next page. Here we are doing an experiment. These are the things you'll be using in the experiment. It's a fairly easy experiment in that you just need to mix the things together. So if we go up to here, you'll be filling this in. So for example, if sodium carbonate and calcium nitrate produced a precipitate, then you might be writing down here white precipitate. If there was no reaction, then you just write no reaction down. I'm not saying these are necessarily right. You'll need to go and do the experiment. And once you've done the experiment, you should be able to have a go at doing the discussion questions. Okay, that's the first task video for this week.